quadratic function. And if you look up here, right here is your standard form. This, the f, whoops, back up there. This is your standard form of the quadratic right there. And it looks just like that, ax squared plus bx plus c. A has to be greater than 0 or you wouldn't have the x squared. If a is greater than 0, the function opens up like this. If a is less than 0, and we have our minimum here at the vertex, if a is less than 0, the function opens downward like this, and you have a maximum point at the vertex. A cannot be equal to 0, because if you didn't have an a, then you wouldn't have a quadratic function. You would have a linear function. The equation for the axis of symmetry, and the axis of symmetry is that line that goes vertically right down through the vertex, and that's not a very good drawing, and separates this into two halves that are symmetric to one another. And that is negative b over 2a. And that will also be the x value of your vertex. So that will also be the x value of the vertex. So if you're given an equation in standard form, that's the easiest way to find the vertex. Then you take that value, plug it back in here, whatever you find for the x value, find f of negative b over 2a, just like we found values for functions before, and that will give you the y value. The y-intercept will be 0, c, whatever this number c is. And the roots, you set the function equal to 0 and solve for x. Or if you're looking at a graph, it is where x crosses the where the graph crosses the x-axis. So an example, looking here at this function, and I'm going to see if I can move this up just a little bit. Oh, that's not what I wanted to do, but so no, I can't. All right, go back here. If I look at this right here, I have x squared minus 9. So I could rewrite that as x squared plus 0x minus 9, because there's no middle term. And so in other words, a is equal to 1, the number in front of the x squared term, b is equal to 0 because there's not an x term, and c is equal to 9. So the direction this goes, this x squared here is greater than 0, or greater than, it's positive in other words, and so it points upward. The axis symmetry will be negative b over 2a, which is negative 0 over 2 times 1, or negative 0 over 2, which is 0. So the axis of symmetry is 0, which is the y-axis right here. Okay, so the axis of symmetry is actually right on the y-axis. That's x equals x. The vertex then, we know the point 0 is my vertex. I have to find f of 0 now in order to find the y value. So it's 0 squared minus 9, or just negative 9. So 0, negative 9 is the vertex, which would be down here at 0, negative 9. The y-intercept is where it crosses the y-axis, or it's 0c, which in this case is also, the vertex is also the y-intercept. Now, where does it cross the x-axis, or how do we find 0? Set the function equal to 0, so we're going to set x squared minus 9 equals 0. The way you solve a quadratic, remember, we're going to factor it, and that's going to factor as x plus 3 times x minus 3, and that equals 0. That means when I set each of these equal to the 0, my roots are x equals negative 3 and x equals positive 3. It's the value of x that will make either of those sets of parentheses or those factors equal 0. And so my roots as points are 3, 0 and negative 3, 0. So right here and right here, and they're symmetric if you notice about this axis of symmetry. So this is negative 3, 0 and this is 3, 0. And if I wanted to sketch in my graph, then it would come, and I'm never very good at drawing with this pen. It would go down and then up like that and go through those points, which I missed, I know. Okay. Our domain is all real numbers, or negative infinity to positive infinity if you're using interval notation. And the range is down here that you can't really see. And I can't move this line up, so I'm going to write over here the range. Okay. The lowest point is negative 9, and it includes negative 9, so you have a square bracket on negative 9, and it goes to infinity. Or you could say y is greater than or equal to negative 9. So I'm going to click off this and go to the next page. Hopefully. We're not working too well. There we go. All right, so go back to my... Now let's look at our example 2. This is a little more complicated equation than what we had. Our A is equal to negative 2, our B is positive 7, and our C is 4. The number in front of the x squared is negative, so that means that it points downward. Now we need to find our axis of symmetry, and you're going to do that with x equals negative b, negative 7, over 2 times a, which is negative 2, which is going to be negative 7/4, or positive, negative 7 over negative 4, or positive 7/4 is going to be the x value of the axis of symmetry. So our axis of symmetry, that's about 1 3/4. So if I was going to draw it, it'd be right in here. Our axis of symmetry would come straight down at positive 1 3/4. So our graph is going to be symmetric about that line. The vertex, remember, the x value is the same as the axis of symmetry. And then I have to figure out what that will be when I, so we have f of 7/4 is going to give us our y value. So we have negative 2 times 7/4 squared plus 7 times 7/4 plus 4. All right, so we have negative 2 times 49 over 16 plus 49/4 plus 4 in terms of 4. Remember, if I want to multiply that by, well, let's figure out what common denominator we need. This is going to reduce, this negative 2. So that's going to make that 49/8. So we're going to have negative 49/8. Okay. And then I need to have 49/4 is going to be 98/8 when I multiply this by 2 over 2 in order to get a common denominator. I want 4 to be 8ths, so I'm going to multiply that by 8/8, and that's going to be plus 32/8. And so 98 plus 32 minus 49 is going to give me 81/8. And that's going to be the x value. Okay. And that's 10 and 1/8. So I've got to go up here to 10 and 1/8, or 81/8. So my vertex is way up here at 7/4 and 81/8. And again, that's not pretty because it's a fraction, but you got to learn to handle fractions. The y-intercept is at 0, 4 because it's at 0, C. So it's going to cross the y-axis about 4 here. Okay, and so it's going to go over here symmetric at 4. And so I could draw this line down and get a sketch of the graph. Where is it going to cross the x-axis? Well, you might need to try to factor to cross the x-axis. So let's see if we can factor it. Negative 2x squared. I need factors that will multiply to be negative 8x and add to be positive 7x. So they need to multiply to be this and add to be this. And so the two numbers, okay, the two numbers that are going to do that will be 8x and negative 1x. If I multiply those together, I get negative 8x squared. If I add them, I get positive 7x. So we're going to split that middle term like this and group. Factor out here negative 2x, and that'll leave me with, no, I'm sorry, just negative x. Okay, I'm going to factor out a negative x, and that'll leave me with x plus 1. And here I'm going to factor out a 4, and that'll leave me with x plus 1. Okay, 2x plus 1, excuse me, on both of these. That leaves me with 2x plus 1. So my two factors then are 2x plus 1 and negative x plus 4. Okay. Now it would have been easier, and I'll show you another alternate way to do this to get the same answers. Now let's solve each of these, set each equal to 0, and solve for x. And so for this one, x is going to equal negative 1/2. That's the value for x that would make that first factor 0. And this other one is going to be 4. Another thing I could have done to make this maybe factorization a little easier was to divide each by negative 1. So in other words, I'd end up with 2x squared minus 7x plus 4. Divide everything by negative 1. And then I could have factored it, and it would have actually come out the same way, because this time I would have needed a negative 8x and a positive x in order to come out with this would have been minus 4 when I've divided everything through by negative 1. And so then when I split my terms, I would have had 2x squared minus 8x plus x minus 4. Factor out here a 2x, and that would have left me with x minus 4, and this would have been plus 1, and that would have left me with x minus 4. And then when I solve it, I have x minus 4 as a factor, and 2x plus 1 as a factor. And you can still see that you come out with x equals, you come out with negative 1/2 and 4. Okay, so you still come out with the same answers. If you divide through by negative 1 before you start, sometimes this factorization is a little bit easier. But at any rate, we found out that our roots were negative 1/2, 0, and 4, 0. The domain in a quadratic is all real all the time, or from negative infinity to positive infinity. And the range, now it goes from a top down. So the lowest value is negative infinity. You always put the lowest first, and it goes up to 81/8 is your range. And it includes the 81/8, so you have a square bracket there. Okay. So that is the notes for 3-2. Our standard form of